Monte Carlo simulation. Session prerequisites. Browse through our earlier material on Monte Carlo simulation. In preparation, please have RStudio open on your computer and follow along. Maximum benefit guaranteed. Learning objectives. Run a Monte Carlo simulation with project risks. Profile the impacts on the project's schedule and cost.
We begin a Monte Carlo simulation by generating a large set of uniform random numbers between 0 and 1.
Again? But this is an easy peasy variable.
Yes, Lisa, but a highly useful one. Let's take up the first generated number and call it u. And for the sake of my example, let's say u is 0.4. I will then look at each of the numbers on my list of risks over here and compare u, which is 0.4, with the probabilities here. Now, 0.4 is certainly not less than 0.15. And if I go down, it is less than or equal to my risk over here, which is estimating errors. So I will turn the switch on this particular risk which happens during implementation, and it becomes an issue. Going further down, I have this being less than 0.7. I will turn this risk on, and no other risk becomes an issue in this so-called round.
Meaning it's going to cost us?
On the project's schedule as well as on the costing. When I have gone through all of the risks on this list, we will call it the end of one round of simulation. Next, we look at all of those risks that have become issues. I just pointed out two of them, and total up the costs that are associated with that in terms of schedule as well as in terms of the cost of the project. We will record these costs and then pick up our next random number.
And go through it all? We need a computer.
Yes, thank God we have it at our fingertips, literally.
How many rounds do you propose?
It's a free country, Lisa. So how about we go with 1000? There are good commercial packages for spreadsheets such as At Risk. What we will do is to run our simulation with R.
Is this intermission? This will take an hour.
Not really, Lisa. More like a minute. Here's an R script that I have written. Don't get caught up in finding out how it works. Just hit source. What we have here is the list of risks which are plotted with the schedule impact on the x-axis and the probability on the y-axis. Now click on any of these points if you want to know more about the particular risk. I have done that. I hit finish, and these here are ISO quants. Points on them will have identical risk exposures.
Meaning the dots on the blue lines are comparable?
You mean these risks, Lisa? Kind of. Given that there are a slew of risks on a project, managers must know which risk they must handle first. It's not as straightforward as the one with the highest cost. We looked at schedule impact on the left. We are looking at cost impact on the right. So the risks can spread out differently because they have different impacts in cost compared to different impacts on calendar months. If I want to know more about a certain risk, I can always click on that, as I have done here, and hit finish. Does all of its calculations and gives me these diagrams.
I love these colorful fountains.
These are histograms of added costs from the risks on the project based on 1000 rounds of simulation. Look at each round of simulation as if Lady Luck rolled a die that yields a number between 0 and 1. Based on this number, we converted some of the risks on our list to issues. We then calculated their impact on the project's overall schedule and cost. Next, we found out what would happen if Lady Luck rolled her die 1000 times. With every roll, we calculated the impact, schedule and cost stretch. The profiles of these 1000 numbers are what you see. Because risks have uncertainty, it's prudent to talk about their impact on a project in probabilistic terms. For example, it's more likely that the project will stretch by 20 calendar months rather than by 40 calendar months. A project manager can arrive at a much more realistic estimate of the rollout date if she factors in the middle 50% of these stretches. If the client team knows how these risks impact the project, then they could sit across from the team that's implementing the project and proactively work on eliminating some of the risks. What happens in industry is some project managers just tend to add a buffer to the time estimate that their teams have arrived at. And this practice is a recipe for disaster.
Looks like the PM is a risk himself.
One that bites the entire team throughout the project's life cycle. Now you know better with Monte Carlo simulation.